welcome to Learn Your Color Computer. So let's begin. I'd like to say a few words about the biggest problem in the computer community today, and that's the closet computers. They're the ones that end up in your closet, alone and neglected, after a few fun hours with playing some games. This usually takes place a few months after Christmas, when somebody buys a color computer for the kids to play with. Then, when the fun wears off, into the closet it goes, to sit and gather dust, never to realize its full potential. Some folks may have just had it break down on them and decided not to get it fixed, even for a blown fuse. Well, this has gone on for too long now. With the millions of computers in people's homes today, only a few thousand of them have taken the time to learn their computer and take advantage of the remarkable power available in the small white case. Some people have even used their computers to run their own businesses. But this is not enough. If everybody who owned a closet computer was to become a serious color computer user, we'd be a more powerful group than any other. And this is what the series of shows is all about. So let's begin. Hi, and welcome to the 8th installment of Learn Your Color Computer. In this installment, I'll teach you how to use the basic commands of ASCII, character string, motor, audio, point, and poke. Before I go into how to use the ASCII command, I have to explain something to you first. Each and every character that the computer can generate has an ASCII value ranging from 0 to 255. The name ASCII is an abbreviation meaning American Standard Code for Information Interchange. To obtain these codes, you must consult the glossary of your Color Basic Manual. But for now, just use the codes I'm going to give you here, which will not go below 32. Now let's get into the ASCII command. This command is used to obtain the ASCII code of a string or a string variable which is enclosed in parentheses following the command name. If a string or string variable of a length of more than 1 is specified, the command will execute the function on the first character of the string. For instance, try something like this. Print ASCII, open parentheses, quote, this is a string, quote, close parentheses, and press enter. The computer gives you a result of 84, which is the ASCII code for the capital letter T, or the first character of the string. If you use a single character, as you're supposed to, you should get something like this. Print ASCII, open parentheses, quote, A, quote, close parentheses. The computer responds with a value of 65, which you'll notice is the ASCII value of the capital letter A. This command is also used with a string variable, except with the variable you don't need to use the quotes. As for the character string command, it's really a simple command to master. The command is used with an ASCII code enclosed in parentheses following the command's name. If you were to type something like this, print character string, open parentheses, 72, close parentheses. The computer would respond with a capital letter H. Simple enough? Well, now if you want to make longer strings, you can use the string version of plus or string addition to create them something like this. Say if we start with a line 10 and say print character string, open parentheses, 72, close parentheses, plus character string, open parentheses, 69, close parentheses, plus character string, open parentheses, 76, close parentheses, plus character string, open parentheses, 76, close parentheses, plus character string, open parentheses, 79, close parentheses. Now run the program, and the computer responds properly by printing the word hello. The ASCII code used with character string is a numeric variable, so you can change and or just plain use other numeric variables with one or more character string commands. Now let's talk about the motor command. This command is in reference to the cassette recorder's motor. You use this command with either the word on or off following the command name. Press the play button on your tape recorder and type these commands in. Motor on, motor off. In case you didn't notice what happened, type the commands again, and this time watch the tape recorder spindles. Motor on, motor off. You'll notice that as soon as you typed the motor on command, the spindles of the tape recorder started turning and stopped again when you typed the motor off command. Press the stop button on the recorder for a moment while I tell you about another related command. The audio command is used to turn on the sound from your tape recorder and redirect it through your television speaker. The audio off command turns the sound back to normal. If you have a pre-recorded tape of music or voice or whatever else, place it in your tape recorder and press the play button on the recorder. Now type in the following commands. Motor on, colon, audio on. Press enter. Now sit back and enjoy the nice quality of music which is being piped through your computer into your television speaker. And you thought your computer could only make beeps. Now type these commands. Motor off, colon, audio off. Your tape recorder should stop turning now, and the sound coming into your television monitor or amplifier should also be turned off. Now let's take a look at the ever-popular point command. It's used to test a screen location for a certain color and put the result in a numeric variable. This command uses two pieces of data, which are enclosed in parentheses and each separated by commas. The first piece of data is the column, which ranges from 0 to 63. And the second piece of data is the row, which ranges from 0 to 31. Just like the set command. The result will be one of your 9 color codes ranging from 0 to 8. The result code is what is returned, and it represents the current color of the point specified with the column and row coordinates. To better understand how this works, type in this short program. Now we'll start off by clearing out memory with new. And we'll start with line 10, where we clear screen to color 0, colon, and we'll say that C is equal to random 4. Now we go over to line 20, where we set 31, comma, 15 with C, our random color. Now in line 30, we check to see if point, open parentheses, 31, comma, 15, close parentheses, equal 2. And if it is, then we print at 0, comma, quote, location 31, comma, 15 is blue. Then we jump right over to line 40, where we check to see if point, open parentheses, 31, comma, 15, our old screen location, is equal to 3. If it is, then print at 0, comma, quote, location 31, comma, 15 is blue. Then we'll set up a nice little time delay so that we won't get our information too fast with a for next loop, which counts the variable t from 1 to 500. Next t. Then line 60, we'll start our loop over again with go to 10. Now, run the program and watch the screen. You'll notice that every time the point at 31 and 15 comes up yellow or blue, it's reported by the program. This is because the point is being tested. And if the resulting code is a 2, then the point is definitely yellow. If it comes up as 3, then the point is indeed blue, as per the basic color codes we're using. And finally, let's take a look at the Polk command. The Polk command is used to physically change the contents of a memory address you specify. This command is used with 2 pieces of data, each separated by commas following the command name. No, we don't need parentheses on this one. The first piece of data is the numeric variable, or number, which represents the memory address you want to change. The second piece of data is the number, or numeric variable, containing the data you want placed in the specified memory location. Unless you have loaded and run a program to place you in the all RAM mode, as we call it, or are using a color computer 3, the memory addresses you can access using Polk are from 0 to 32,767 and from 65,280 to 65,535. The data range you can use is considerably smaller and ranges from only 0 to 255. There is no Polk that you can use that could actually hurt your computer. Some Polks can go as far as making the computer halt all operations. But that is fixed by simply turning off the power and turning it back on. Remembering, of course, the precautions necessary to protect your mass data storage devices. So that you can better understand how this command works, type in these commands and take notice of the results obtained. First, we'll clear out memory with new first. That way we'll know nothing's in there to interfere with what we're messing with. Okay, now first we'll poke the address 32,000 with the value of 10. Okay, so now we've taken address 32,000 and placed the value of 10 in that address. Now to make sure we have it, we'll print peak, open parentheses, 32,000. And it does indeed come up 10. This works pretty good. Let's try another one. Let's say, print peak, open parentheses, 32001, close parentheses. Okay, so we know a value of 0 is currently there. Now we'll poke 32001 with the value of 42 to make the change. And again, we'll print peak, open parentheses, 32001. And now we do know for sure that that memory address was changed. This is definitely proof positive that a data change in memory really and truly happened. It becomes rapidly apparent how this command works and how easy it is to use. You'll see how handy the Polk command can be in programs that we will write in later shows. Now before we leave for this time, let's go over the commands we've learned in this show and what we learned about them. First, we learned about the Ascii command and how it can be used to obtain the decimal value of any character that the computer can generate, or by using a nice long string with it, get the ASCII value of that first character in the string. We also learned about the character string command and how it can be used to either print a numeric variable or a constant or whatever we want to use to generate characters. And we also learned about the motor command and how it can be used to turn on and off the cassette recorder's motor. We also learned about the audio command and how we can use that to take audio from the tape recorder and send it through the monitor speaker. Then we learned about the point command and how we can use it to test any one of the screen locations on the screen to see if it's a specified color or whatever color we want it to test it for. Then finally we learned about the Polk command and how it can be used to change any memory address in the computer to whatever we want it to be. I'd like to mention something about this point command which we've just gone over. This point command can be used to test any spot on the screen to see if it's changed color. Now when the spot on the screen changes color, we can know if there's any activity going on the screen at all. So that later on when you write adventure games or arcade type games in which colors will be moving around on the screen, you could use such a device to find out if, say, an object you're aiming at is being struck by a projectile being thrown. Say, for instance, if the object that you're aiming for is in color blue and the projectile you're going to throw at it is colored yellow or red or whatever, what you do is you test to see if that spot where that object is blue. And when it changes to the color the projectile is, you'll know the object that you were aiming at has been hit. You then can go into any other part of the program, such as a spot to make a noise due to the fact that the object was hit, or just back into a loop where we test the beginning of the program again. So let's go over that point command again. Start off by clearing out memory with new. Then we'll start with line 10, where we clear screen to color 0, colon, and we'll say that C is equal to random 4. Now we go over to line 20, where we set 31, comma, 15 with C, our random color. Now in line 30, we check to see if point, open parentheses, 31, comma, 15, close parentheses, equal 2. And if it is, then we print at 0, comma, quote, location 31, comma, 15 is blue. Then we jump right over to line 40, where we check to see if point, open parentheses, 31, comma, 15, our old screen location, is equal to 3. If it is, print at 0, comma, quote, location 31, comma, 15 is blue. Then we'll set up a nice little time delay so that we won't get our information too fast with a for next loop, which counts the variable t from 1 to 500. Next t. Then in line 60, we'll start our loop over again with go to 10. Now, run the program and watch the screen. You'll notice that every time the point at 31 and 15 comes up yellow or blue, it's reported by the program. This is because the point is being tested. And if the resulting code is a 2, then the point is definitely yellow. If it comes up as 3, then the point is indeed blue, as per the... Thank you for watching. We hope that you've enjoyed the show and that every person that watched will benefit from the information we've supplied. Remember that using your computer is a process best learned by repetition, so spend a little time with the computer and get to know the information we've given. Remember, if you have a problem with any of the information we've supplied, give us a call. One of our many experienced members of our club will be more than glad to help you with your information. If you missed a show, let us know. We can have a tape of the show you missed ready for you to view at the next meeting. That's about all the time we have for now. So tune in again next time when we continue to learn your color computer.